Hey guys, how's it going? We're gonna be starting a new series that's gonna be paired with another series in this channel, and they're both gonna be about machine learning, and they're gonna be talking about how the machine learning methods work in the background. Now we're gonna focus in 4 different steps. In this series, we're gonna focus on the first 2 steps, which is we're gonna talk about the motivations behind these methods and how they came to be, and also the mathematical derivations that follow to these methods. For the 3rd and 4th step, which we will be implementing them from scratch with Python, and also implementing them using existing libraries from Python, that will be in another series. So this series is focused more on the mathematical background and the motivations behind these methods that are used today. After this series, you can expect to get a better understanding of these machine learning methods, and when you do have a problem at hand, you should have a decent idea of which machine learning method to use. You should have at least the intuition to know which method to use. And secondly, you should hopefully, I wish you can see that these machine learning methods can be understood pretty easily with the right explanation. Now, what you need for this series is somewhat of a math background. Some calculus and linear algebra would be good. Otherwise, it's still possible, but it'd be a bit hard to follow along. For the first part of every method that I introduce, I'll be explaining on a very high level, not as many math concepts, intuition, and then for the second part that follows for each method, it's going to be a lot math heavy. However, in the first part of the series, we're just going to be talking about a lot of the notations and the fundamental concept that we need to build upon the other methods. So let's get started. So the first topic we're going to be covering is called, you'll see in the title, is called Regression Analysis. You may or may not have already heard of this term, but all this term means is it's a series of steps that we take in order to learn more about the relationship between one or more independent variable with one single dependent variable. And we'll start off with an example. So the first example we'll start off with is say we took the height and weight measurements of 10 people. 10 people's height and weight measurements, and we format it in such a way that it looks like this: big curly brackets and a lot of round brackets. And so for example, let's say the first person had the height of 103 centimeters. Sorry about that. 3 centimeters. And with the weight of, let's say, 52.5 kilograms. The second person that we measured had a height of 93 centimeters with let's say 63.5 kilograms. And we're going to have 8 more of these measurements because we have 10 people, and we're just going to represent these by those dots over here. Another way to write this is to represent, here's our curly brackets again. So these two things are the same. So the first person, so another way to write this is to say x, which represents measurements for height, y, which represents measurements for weight of each person. And what this means is that xi is the height measurement of any given ith person, and y is the weight measurement of any given ith person. For example, if we let I be 2, that means we want x2, y2, which is equivalent to saying we want the measurement of 93 centimeters and 63.5 kilograms in weight, and which is the second person's measurement. So this is what this means. And intuitively, I can take in values anywhere from 1 all the way to 10. So this should make intuitive sense, and we'll use this kind of notation for most of our series. So now that we have the notation down, let's get into the terminology. So let me write down what we had before just now. We have this xi, yi, I goes from 1 to 10, and remember x is height and y is weight. So like I said before, we're looking for regression analysis, we're looking for the relationship between one or more independent variables and one dependent variable. And also in statistics, we usually like the x's to be the independent variable and y to be the dependent variable. So in this case we actually have x. Sorry about that. We actually have x to be the independent variable and y to be the dependent variable. So now that we picked our variables, one to be independent and the other to be dependent, it becomes much clearer on what problem we're trying to solve with regression analysis. What problem we're trying to solve is to see what kind of response or how dependent is y on the independent variable x. So in our case, we have y as the weight, x as the height. So let's write this in clearer terms. So we have height. So this is height, weight, right? So we're trying to figure out, so remember, height in this case is x, which is the independent variable, and we can have many of those, one or more of those, but we can only have one dependent variable, which is also y, and that's the weight. And what we're trying to figure out here really is, how does changing the weight affect changing y? Affect the change in weight. So for instance, how does me increasing the height, so finding a taller person, how does that change the weight? Does it make them lighter, or does it make them heavier? Similarly, if I found someone that's shorter, which has a lower height measurement, does that make them lighter or heavier? So those are the questions that regression analysis helps us to answer. Obviously, this is a very, very generalized definition, but that's really what it tells us. So mathematically, let me write this again. Mathematically, these xi's and these yi's, the x's are called covariates. The x's are called covariates. It's, there are independent variables, but this is the name that statisticians like to call them, which are covariates. Variates just means random variable, and the just means the x's we have control over. So we have control. So in this case we have control over what the height of the people that we find to put in the experiment, but we may not. But we don't have control over the weight that they have. That's where the control comes in. And for the y's, we like to call that, well, it's not y. Yeah, for the y, we call that the response, which should make sense because in every regression analysis problem, we are always trying to see how does y respond to the covariates. How does y respond to changing the independent variables and covariates? And in statisticians, or just in general in math, we like to put that in a nicer form instead of the form that I showed before. So what does that mean? Well, we like to use vectors, which means x now is a vector of 10 by 1 in our case. So what does that mean? That means we have, using the same subscript, we have x1, x2, all the way down to x10, and these are just the measure. So for example, x1 is the measurement of height of the first person, x2 is the measurement is the height of the second person, and x10 is the height of measurement of the 10th person. Similarly, so 10 is talking about the number of rows, and 1 is talking about the number of columns. Similarly, we also have our weight measurements, which have y1, y2, all the way to y10, because we have 10 people. This is also 10 by 1. If you're not familiar with linear algebra, you'll see why we put it in such a way that's in a vector. But if you do understand linear algebra, it'll be very helpful once we get into the mathematical derivations for a lot of these methods. So just a recap so far. We really just changed the formatting of something that was easy to understand and now a little bit harder. So we started with saying, okay, let's have 103.2 centimeters. Sorry about that. Centimeters, and then we had like 93 kilograms, and then we had 10 of these, and then we turned it into in this format where the I represents the ith person's measurement, and then finally we turned it into matrices over here, and they all mean the same thing, just in different forms, right? This is a 10 by 1 vector. This is a 10 by 1 vector for the y. Now, one last thing I want to add is, remember that I said there could be one or more. There could be one or more covariates. There could be one or more covariates, but only one response variable. So what does that mean? So in our case, we said that our one height. The question that regression analysis answers, the answer is how does weight respond to some height, right? This is what regression analysis answers. So this is this is the question it answers. However, in the case that we have more than one covariate, we could for example have this. Let's say we had 2 covariates and we still had one response variable. What does this mean? Well, say we had height and now we added BMI. What does this mean? And then we still have height. Well, this means that the question regression analysis will answer is, instead of asking how does weight respond to some weight, it's how does height, sorry, not height. How does, wait, sorry about that. This is weight over here. This is weight. How does weight respond to some height and BMI? So what pattern do they you know? This is the also, oh, wrong color. This is the answer. Why is this not changing? What is the answer? Right, to this question. And that's what regression analysis answers. Finally, notation-wise, let me clear this up. Notation-wise, because now we have 3 covariates, we write it in such a, 2 covariates in such a way that, so we still have this. So the ith person, so for example this, the third person will have, sorry about that, the third person will have the height of x1, 3, so that's a measurement, so this is in cm, this is in BMI, the whatever measurement that they use, so they'll have the value of whatever x223, that's the third person of BMI, and the third person's weight, which is y3. And yeah, so the first subscript represents the, in this case we write it as j, but the jth, this is j, so this is xij, this is right like this. Some people like to write it like this, but I'm just gonna write it like this. So the jth covariate, so for example, if we wanted x14, that means we're looking at the fourth person's height. If it was x24, we're looking at the fourth person's BMI. So it's the jth covariate and the ith person. That's the notation here. As for the if we put it in matrix form, remember before we had, we had a 10 by 1 matrix, right? Because we had one covariate. Right, we had x1, x2, x10. Now we're going to have, you guessed it, 10 by 2 covariate, 10 by 2 vector. So we're going to have x, let's make this just slightly bigger. We're going to have x1, 1, x2, 1, x1, 2, x2, 2, and it goes on, and then we have 1x, 110, and then we have 1, 2, 10. So the first column represents all of the measurements. The column number represents the measurement of that person, so the covariate of that person. The first column represents the height. The second column represents the BMI, in our case, and the row number represents the ith person. So the fifth row, for example, represents the height measurement of the fifth person and the BMI of the fifth person. And y doesn't change. We still have 10 by 1 with y1, sorry, not this, just y2 and then y10. So I hope that you can better understand what regression analysis is. It's a very, we're going to be using this throughout our tutorial. All we're really doing is trying to figure out different ways of explaining the relationship between our data points. So for example, there's linear regression, right, which is just trying to explain our data through trying to fit it through a line. And then we could also have, ridge and lasso, and the list goes on, and all of these are building blocks for all the machine learning we use today. So stay tuned for the next tutorial, which will be talking about linear. Thanks for watching.